Hello everyone. Today we are going to discuss radiation. Now, radiation is one of the most fundamental mode of heat transfer, and most of the heat that is coming from sun to earth is coming because of radiation. Radiation don't need a medium. There is no medium between earth and sun. There is only space, and the heat is coming. And the amount of heat, the intensity of heat, the farther the planets are, the intensity of heat will be lower. Intensity of heat proportional to 1 by distance square. So more distance, square of that, the heat will be less, right? The intensity of the heat will be less. That's why Mercury is so hot, and because appropriate amount of heat comes to Earth. Earth can have life, and Earth have water, but other planets don't have. If you go beyond Earth, Mars, Jupiter, they are very cold, and if you go Mercury, Venus, they are much hotter, so they cannot sustain life, or there is no life as we know it. Earth have the optimum condition to sustain life because Earth have proper amount of heat coming from Earth. To life evolve in a planet, heat is very important, and the exoplanet research, there's exoplanets where life could also be there. It, we assume that temperature is close to Earth temperature, otherwise life would not be there. So one of the primary um, condition for existence of life is right temperature, right heat. So the radiation that is coming from Earth to Earth, also radiation you can see, moon is shining because the radiation of sun, and even lights are radiating. Light have three, like LEDs, they have 3000 degree temperature. Because of that they radiate that light, photons. Photons is a type of radiation, but also the heat radiation that is not in visible region, that is infrared. There's also electromagnetic wave, and infrared spectrum, that is heat radiation. Maxwell proved that, and it create that heat that is being radiated from the from any object, from any source, is because of the because of the vibrations of the molecules on the molecular level and atomic level. The vibration of charged particles create that heat. Everything is vibrating. Everything with temperature higher than 0 Kelvin is vibrating in a certain frequency, and because of that vibration it's generating the radiation. Your mobile is generating the radiation, everything you are seeing around you, the wall is even generating the radiation, right? But everything have a radiation, but due to the temperature difference, the radiation will be different. When the temperature of the mobile battery is high, then the radiation level is much higher. If the temperature reduces, the wavelength will increase, so the energy of the radiation will reduce. The more the wavelength, the less the energy. And temperature of the source is proportional to 1 by wavelength temperature. Any source that is emitting any radiation, that is proportional to 1 by wavelength of the radiation. Wavelength of the radiation will reduce as the source temperature will increase. Okay, now object have a emissive property. Emissive property is object when the object have a temperature. Because of the temperature, and mainly because of the surface temperature, object is radiating a certain amount of heat. Now the heat that object emits, that heat is due to the temperature of the object. With the temperature higher, the object will emit more heat, mainly because of the surface temperature. Object emits heat, like earth ground is emitting heat, but inside earth the temperature is very high. Emission of heat is not due to inside core temperature of earth, due to the ground temperature, right? So every object, the temperature of the body will be given in your question, and you have to find out the radiation, heat rejected and all that. But you must understand that's actually the surface temperature, not the inside body temperature. Okay, So let's say if the object's emissive power is determined as heat radiated by the object per unit area per unit time, E emissive power is Q by AT. Okay, and any heat falling on the surface, heat follows the law of interference and polarization and reflection and refraction. Heat, if fall in a surface, mainly heat, if the surface is shinier, more heat will reflect. If the surface is not shinier, less heat will reflect. It's dull. A percentage of heat always reflected, a percentage of heat is absorbed, and a percentage of the heat is transmitted. Okay, depends on surface texture, surface color. If the surface is black, then the more amount of heat will be absorbed. If the surface is whitish shiny, then more amount of heat will be reflected, less heat absorbed. Like in hot weather, if you wear clothes that is dark black color, then more heat is being absorbed, okay, and more heat is being transmitted. And so as more heat is being absorbed, you will feel hotter. So in winter, people should wear black clothes because black clothes will absorb more heat. But in summer, if you wear black clothes, clothes will absorb heat, and it will reflect, also transmit heat. So you will feel more hot wearing black clothes. So, and in summer you should wear white clothes, because white clothes, they will absorb less heat, and they will also emit less heat. The object, more object absorb, more heat object will emit. Okay, that we'll see in Kirchhoff's law. Before discussing Kirchhoff's law, from this equation, QR plus QA plus QT, heat transmitted, heat absorbed, and heat reflected, if you divide it by Q, then you get this term. This term you can say as R, this term is A, and this term is T. Okay, so 1 equal to R plus A plus T. A is absorptive power. Absorptive power is how much amount of heat totally fall on the body, and percentage of what the body absorb. Amount of heat body absorb by amount of heat fall into the body. Now if the ideal black bodies, they absorb 100% of the heats. Okay, so like sun is considered ideal black body, because sun, all the heat wavelength 6000 degree temperature sun have, or all stars also have high temperature body, they emit all the heats. So they are ideal black bodies, because the amount of heat they are absorbing, they are also emitting. Black hole is not considered as a black body, because black hole only absorb heat, black hole don't emit heat. Okay, now if you want a surface to absorb heat, you just paint it with black, and it 99%, 98% heat will be absorbed by the surface, right? And there is Ferri's black body. Ferri's made a black body with a small hole. So with hole, if the heat gets in, or energy gets in, that energy mostly and inside that sphere there is black surface, so that energy will reflect inside the sphere and won't get out. So like that 99.9% energy you can you can absorb inside the sphere. That is a ideal black body. That's what we consider as ideal black body. Okay, so fine. Now let's discuss Prevost theory. Prevost theory is every object is releasing heat, every object is absorbing heat in any temperature except above 0 degree. Every object is emitting heat, but the higher the temperature of the object, they will release more heat. Okay, so if you put an object in a room temperature, an object have higher temperature than room temperature. So if the object have higher temperature than room temperature, then object will release heat. A higher temperature than room temperature, then object is absorbing more heat than releasing heat. Okay, when T surrounding is greater than T0, then the Q in, that is going in, will be more than Q out. Object have more temperature, so object will release more heat. T of the object, Q emitted, that is more than Q in. So in this case, as object is releasing more heat, the object's temperature reduces. So if temperature is of the object high and room temperature is low, object is giving out more heat than object is taking in, and like that object's temperature will reduce, and when the temperature will become surrounding temperature, then object is in thermal equilibrium. That doesn't mean the object is not giving heat or not taking heat. The object is giving the same amount of heat that is it is taking. Okay, so always there is a transfer of heat, but the amount of heat that is being transferred depend on the temperature of the object. That is Prevost theory.